Voyager did not map black holes. That is the first thing to say, because the mistake matters. Not as a minor correction, not as a technical footnote. It matters because the sentence sounds almost believable. A spacecraft older than many people alive today is still moving outward, still carrying instruments beyond the sun's familiar weather. If any machine felt capable of finding something hidden, it would be Voyager. But that is not what happened. Voyager is not a black hole telescope. It is not drawing a secret map of collapsed stars. The cameras that once gave Earth its first intimate views of the outer planets are long silent. Voyager measures particles, fields, plasma waves, cosmic rays beyond the sun's protective reach. A faint signal leaves the spacecraft and crosses the emptiness back to Earth. By the time it arrives, it is less a voice than a surviving thread, a relay click, a whisper pulled out of static. Engineers listen because it tells us what space is like where the solar wind no longer rules. That is Voyager's real territory. Not black holes. The boundary. The edge of the sun's influence is not a wall. There is no shining gate where the solar system ends and the galaxy begins. The heliopause is a condition, not a fence. On one side, particles blown outward by the sun still shape the environment. On the other, the local interstellar medium presses back. Voyager crossed that condition, and the crossing mattered because it was the first time a human-made object left the bubble that had quietly enclosed every planet, every comet, every civilization, every breath ever taken on Earth. That achievement is immense. It is also tiny. This is where the title becomes useful by being wrong. It forces the real question into view. Why do we imagine that the farthest object must be the best witness? Why does distance feel like authority? Why does a machine moving away from home seem more capable of revealing the galaxy than instruments that never leave Earth orbit, or even Earth itself? Part of the answer is emotional. Voyager feels like a body. It has a direction. It has a journey. It has age. It has a fading power supply and a memory full of planets. We can imagine it moving through darkness the way we imagine a ship crossing a black ocean. A physical thing seems to earn knowledge by going somewhere. Black holes resist that story. They are not usually found by flying close and looking through a window. Most are dark. Many are dormant. Some announce themselves only when they feed, or when they merge, or when a visible star moves in a way it should not move alone. A black hole may enter human knowledge not as an object, but as a debt in the motion of something else. A star drifts across the sky. For years, its position is measured again and again. The movement is not random. It bends around an unseen partner. The visible star seems to circle emptiness, but emptiness with mass is not emptiness. If the hidden companion is too heavy, too compact, and too dark to be an ordinary star, then absence begins to acquire a name. That is how a map of black holes can begin. Not with a spacecraft arriving. With a wobble. The difference is easy to miss because maps have trained us badly. We think of a map as a picture of places. Coastlines, roads, mountains, borders, names printed over territory. But a black hole map is often not a picture of a thing. It is a map of consequences. It is a record of what cannot be seen, forcing the visible universe to confess. This is the deeper contradiction. Voyager has traveled farther than any spacecraft, yet it is almost useless for finding the nearest known black holes. Gaia, much closer to home, can reveal black hole candidates by measuring stellar motion with extraordinary precision. The Event Horizon Telescope, made of radio observatories spread across Earth, can reconstruct the shadow region around supermassive black holes. Gravitational-wave detectors buried in our own planet can feel the passing tremor from black holes colliding in deep space. Voyager moves through space. Those instruments measure distortion, and distortion is often more powerful than travel. The danger in the title is that it turns this into a cheap miracle. No probe has slipped into some forbidden black hole district. No old spacecraft has returned a forbidden map. The real shock is that our best maps of black holes are built from patience, absence, and disciplined doubt. Science works around the silence. It watches gas accelerate and heat before falling. It watches stars orbit invisible mass. It watches radio emission curve into rings around darkness. It watches space-time itself ring after a collision. Each method is incomplete. Each has uncertainties. Each can be misread if pushed too hard. But together, they build knowledge that does not require touch. Voyager, by contrast, is touch. Not human touch, not warm touch, but contact in the most austere scientific sense. A sensor sits in a place and lets that place act on it. Charged particles strike. Magnetic fields register. Plasma waves leave signatures. Cosmic rays arrive with different intensities. The spacecraft does not infer the local environment from across the galaxy. It is inside one narrow thread of it. That narrowness is the point. Voyager is not a God's eye view. It is a needle moving through a single stitch of interstellar space. Its greatness comes from the fragility of that position. A machine built in the 1970s, carrying instruments from another technological era, now measures conditions no human body could survive, at distances no repair crew can cross, with power that fades year by year. There is a quiet hum in that image, a machine in the cold, not discovering everything, not becoming myth, just continuing to report what touches it. That is enough. But it is not the same as mapping black holes. The distinction matters because cosmic scale punishes our instincts. Voyager can be beyond the heliopause and still not be meaningfully close to another star. It can be the farthest human artifact and still sit inside the shallowest margin of the Milky Way. The nearest known black holes are not waiting just outside the solar system. They are measured in light years, hundreds or thousands of them. A light year is not a poetic distance. It is a year of light traveling at the universe's fastest speed. Voyager has been moving for nearly half a century, and that does not bring it close to even 1 light year from home. This is where the body understands what the mind tries to smooth over. Children can become grandparents, while the signal keeps thinning across the dark. And after all that, the machine has barely begun the kind of distance that astronomy uses casually before breakfast. So when a headline says Voyager mapped black holes, the falsehood is not only technical. It compresses the universe until it fits a human adventure. It makes cosmic distance behave like a coastline. Sail far enough, and the hidden continent appears. But the galaxy is not a coastline. And Voyager is not sailing toward a black hole map. The title says something is not where it should be. That part can survive. But the misplaced thing is not a black hole. It is our intuition. We keep putting discovery inside the traveler because travel is the old human grammar of knowledge. Cross the sea, climb the mountain, enter the ruin, reach the edge, bring back the proof. Modern astronomy has broken that grammar. The universe did not wait for us to reach everything. It left consequences. And those consequences, measured carefully enough, became the map. The doorway Voyager crossed was not a doorway in the way the mind wants it to be. There was no final planet behind it, no last ring, no visible border where sunlight lost its passport and interstellar space began. If a camera had been awake and looking outward, it would not have seen a wall ahead. It would have seen darkness, stars, and the same difficult nothing that had filled the view for years. The crossing happened inside the instruments. Particles changed. The pressure balance changed. Cosmic rays from beyond the solar system became more common. The solar wind, that restless stream of charged particles leaving the sun, no longer dominated the neighborhood around the spacecraft. The sun was still there, still gravitationally holding planets and comets in its long reach, still the brightest fact in Voyager's memory. But its breath had thinned until something older and wider pressed through. That is the heliopause. It is not the edge of the solar system in the simple sense. Gravity does not stop there. The Oort cloud would extend vastly farther, a loose reservoir of icy bodies still bound to the sun. The heliopause is the edge of a different kind of kingdom, the region where the solar wind has enough force to carve a bubble inside the local interstellar medium. Every human life has unfolded inside that bubble. Not metaphorically, physically. Every city, war, language, harvest, orbit, and funeral happened beneath a star that was not only shining, but also pushing. The sun has been throwing charged particles outward, wrapping the planets in a moving environment, shaping the magnetic weather through which Earth travels. We usually call space empty because our bodies are too large and too wet and too slow to feel what instruments feel. Voyager felt it. It felt the solar system stop behaving like the solar system. That sentence is dangerous if left too simple. Nothing snapped, nothing ended. The spacecraft did not pass through a door into pure galactic truth. It crossed a boundary that shifts, breathes, and responds to the sun's activity. The heliosphere is not a polished glass sphere. It is more like a weather system carved into plasma, lopsided, dynamic, shaped by motion, pressure, and magnetic fields. Imagine standing in a room where the air has always moved from behind you. You never noticed it because it was the only wind you had ever known. Then, after years of walking, the air changes direction. It does not announce itself. It only touches your skin differently. A faint hiss moves across the threshold. The room has not ended, exactly, but the force that made the room familiar has lost control. Voyager's crossing was that kind of event. Not visual. Environmental. This matters because the false black hole premise depends on a misunderstanding of what distance does. The public imagination often treats interstellar space as if it were the real universe, and the solar system as if it were a walled garden. Once Voyager left the garden, the story goes, it entered the larger truth. Hidden things should now become visible. The galaxy should open. The black holes should take their proper places on the map. But interstellar space is not a balcony above the Milky Way. It is local space without the sun's solar wind controlling the particles around you. That is astonishing. It does not grant omniscience. Voyager's achievement is intimate, not panoramic. It tells us about one path through one boundary, sampled by one aging machine. The spacecraft does not look down on the galaxy. It does not gain a new angle on the Milky Way's hidden population of black holes. It sits inside a thin stream of measurements, one point after another, while Earth reconstructs the changing environment from delayed signals. The signal is part of the story. It leaves a transmitter with less power than a household light bulb and spreads across billions of kilometers. By the time antennas on Earth gather it, the message is almost gone. It has to be caught by enormous dishes, pulled out of noise, corrected, decoded, and believed carefully. A soft beep from the dark becomes a number. A number becomes a line on a plot. A line becomes evidence that the sun's shelter has given way. That is not less beautiful than a black hole map. It is more disciplined. Because the real boundary Voyager crossed is not a cinematic edge, but a measured change in conditions. The plasma environment changed. The cosmic ray environment changed. The spacecraft entered a region where particles from outside the heliosphere could reach it with less interference from the solar wind. The galaxy did not reveal itself as an image. It revealed itself as a change in what struck the instruments. This is how much of science actually happens. Not as revelation. As pressure changing at the sensor. The heliopause also changes the meaning of home. Before Voyager, the solar system could be imagined mostly as a sequence of worlds. Mercury, Venus, Earth, Mars, the giant planets, their moons, the icy bodies beyond Neptune. A map made of objects. But Voyager helped turn the solar system into a body with an atmosphere of its own. Not an atmosphere of air, but of wind, field, particle, boundary, and contact. Home is not only the rock beneath us. Home is the invisible region that protects, filters, and shapes what reaches the rock. That is why the crossing feels larger than the instrument list suggests. Cosmic rays are not dramatic in the way a planet is dramatic. A magnetic field measurement does not sit easily in the imagination. Plasma waves do not make a clean photograph. But these are the things that define whether a boundary is real. They are the fingerprints of a system larger than the planets themselves. A planet can be seen. A boundary has to be inferred from behavior. Voyager did not make the solar system smaller by leaving it. It made the solar system stranger. It showed that the sun is not merely a lamp with planets around it. It is an engine blowing a cavity into the medium between stars. Earth orbits inside that cavity. So does every spacecraft we have sent inward and outward. Every probe, every telescope, every metal object still loyal to the sun's motion. Voyager crossed the place where that cavity weakens. But crossing a boundary is not the same as escaping scale. The temptation is to let the moment become triumph. Humanity entered interstellar space. A phrase like that can swell until it loses precision. It sounds like arrival. It sounds like a door opening into the galaxy. But the more accurate version is quieter and more severe. One machine crossed the region where the sun's wind gives way to the local interstellar environment, while remaining unimaginably far from the stars themselves. That is not disappointment. It is calibration. The soft crackle in the data tells us where one kind of belonging fades. Not all belonging, not gravity, not memory, not the long mathematical tether between spacecraft and home, but the belonging of plasma weather, the belonging of being inside the sun's blown bubble. The black hole story cannot begin honestly until this is clear. Voyager's frontier is local. Black holes belong to a map so large that even nearby ones are unreachable by any machine we have built. If the first message broke the illusion that travel equals cosmic authority, this boundary explains why. Voyager's distance is real. Its courage, if a machine can be allowed that word, is real. Its loneliness is real. But the doorway it crossed was not the doorway to everything. It was the doorway out of the sun's weather. And beyond that doorway, the galaxy did not become close. It became measurable in a different kind of cold. Distance is one of the few words that becomes weaker the larger it gets. At human scale, distance has shape. A road has bends. A flight has hours. A mountain has a summit that slowly rises until it fills the windshield. Even an ocean, for all its danger, eventually gives the traveler another shore. The body understands distance through effort, hunger, waiting, fuel, pain, sleep, and arrival. Space breaks that understanding. Voyager has been moving outward since 1977. It has crossed the paths of giant planets. It has watched Jupiter swell into a banded world and Saturn widen into rings. Its twin carried the story past Uranus and Neptune. It has outlived the people who built parts of it. It has become less an instrument than a surviving habit of civilization. Listen, decode, respond, conserve power, listen again. And still, measured against the galaxy, Voyager has barely moved. This is not an insult to the spacecraft. It is the first honest scale of the story. The machine has traveled farther than any object humans deliberately launched. Its signal takes many hours to reach Earth. It sits so far away that command itself becomes patience. You do not speak to Voyager and receive an answer in the rhythm of conversation. You send a thought into the dark, and much later the dark gives back a number. A faint tone moves through antennas on Earth. It carries the shape of an old machine continuing to exist. That feels immense because it is immense. Then the light year enters the room and reduces it. A light year is often spoken too smoothly, as if it were a unit designed to make space manageable. It does the opposite. It is the distance light travels in 1 year, and light does not stroll. Light crosses the distance from the moon to Earth in a little more than a second. It crosses the distance from the sun to Earth in about 8 minutes. Give that speed an entire year, and the result becomes so large that ordinary imagination loses traction. Voyager has not traveled 1 light year. Not close. Nearly half a century of motion has carried it beyond the heliopause, beyond the planetary story, beyond the easy emotional map of the solar system. But a light year remains ahead as a measure too large for the mission's physical life. The spacecraft is fast by human engineering standards. It is slow by the standards of stars. This is the humiliation built into cosmic distance. Not humiliation as failure, humiliation as proportion, a correction forced onto the mind. The farthest thing we have sent is still close to home when scale changes from planets to stars. The solar system is enormous until it is placed inside interstellar distance. Interstellar distance is enormous until it is placed inside the Milky Way. The Milky Way is enormous until it is placed among galaxies. Every enlargement turns the previous triumph into a local fact. The nearest known black holes make this painfully clear. They are not lurking near the heliopause. They are not waiting just past the reach of solar wind, like predators outside a campfire. The nearest confirmed candidates are measured across hundreds or thousands of light years. Gaia BH1, one of the nearest known stellar black hole systems, is roughly 1,500 light-years away. Others are farther. In galactic language, that is nearby. In human-machine language, It is unreachable. Hold that distance without smoothing it. A black hole 1,500 light-years away is not 1,500 years away for us. It is 1,500 years away for light. A photon can make the trip in 15 centuries. A spacecraft like Voyager cannot turn that number into a mission plan. It cannot convert it into a route, a budget, a launch window, a patient engineering problem. The distance does not become difficult. It becomes functionally outside the category of travel. Imagine Voyager continuing. Not for another decade, not for another century. Imagine it drifting through the dark, long after its transmitter is silent, long after its power has faded below usefulness, long after Earth has stopped receiving anything but memory from it. The spacecraft continues as metal, as geometry, as a cold artifact moving through a thin medium. It passes no black hole. It enters no dramatic horizon. It simply persists. A granular scrape of dust, if any dust ever strikes it, would be one of the only sounds the imagination can give the scene. The galaxy does not hurry toward it. This is why near becomes a dangerous word in astronomy. Nearby does not mean reachable. Nearby means closer than other things that are worse. A black hole 1,000 or 2,000 light-years away can be one of the nearer known examples, while remaining so remote that Voyager's entire journey is barely a gesture in its direction. The same word that comforts us in daily life becomes almost cruel at cosmic scale. Near the store. Near the station. Near the sun. Near in the Milky Way. These are not the same word. The title's false promise depends on collapsing them. It imagines Voyager as a scout at the edge of a dark forest, finally glimpsing the hidden creatures between the trees. But Voyager is not at the edge of the black hole forest. It has only left the windbreak around one star. The forest is not ahead in any human sense. It surrounds everything, and its objects are separated by distances that make heroic travel look symbolic. That does not make Voyager smaller. It makes measurement larger. Because if travel cannot do the work, something else must. If no spacecraft can approach the nearest known black holes, then the map has to be built without a rival. A star's motion must become a footprint. A ring of radio emission must become a silhouette. A ripple in spacetime must become an event. The absence of light must become a measurable participant in the visible universe. This is where distance stops being only a barrier and becomes a filter. It decides which kinds of knowledge are possible. It prevents touch. It punishes imagination. It forces astronomy to become indirect, patient, mathematical, and suspicious of its own desire for pictures. The farther away the object, the more carefully the evidence must be handled. The more invisible the object, the more important the consequence becomes. Voyager teaches this by failing to be enough. A less honest story would call that failure tragic. It is not. Voyager was never built to solve the galaxy's hidden inventory. Its instruments were made for other questions, and they have answered those questions beyond expectation. But the gap between Voyager and the nearest black holes reveals the deeper architecture of the problem. The universe is not withholding its secrets because we have not sent a probe far enough. It is arranged at scales where far enough may never mean what the body wants it to mean. The body wants arrival. The universe offers inference. A command leaves Earth, a signal returns. Somewhere beyond the sun's wind, an old machine continues along a line that no human eye can follow unaided. It is far enough to change our definition of home. It is not far enough to change our access to black holes. That tension is the real map. Not a chart of hidden objects drawn by Voyager, but a map of our own limits. How far we can send matter, how far we can send attention, how far evidence can travel back, and how quickly human words become misleading when they try to make the cosmos feel local. By the time the nearest known black hole enters the story, Voyager has already taught the harder lesson. Distance is not empty space between 2 points. Distance is a force acting on knowledge. A black hole can enter a map without ever entering a photograph. That is the first rule Gaia forces on the story. The spacecraft does not chase darkness across the Milky Way. It does not point at a black hole and watch a surface appear. It measures stars, again and again, with a patience so extreme that motion itself becomes evidence. A star is never perfectly still. It slides across the sky because the sun, the star, and the galaxy are all moving. It shifts slightly because Earth changes position around the sun, creating parallax. It may brighten, dim, wobble, or drift for reasons that belong to its own system. Most of this movement is ordinary. Some of it is noise. Some of it is the quiet signature of something unseen. Gaia was built for this kind of quiet. From its position near Earth, it scans the sky and measures the positions and motions of more than 1 billion stars. The numbers are not dramatic by themselves. Coordinates, brightness, color, parallax, proper motion, repeated measurements across time. But if the same star is watched with enough precision, its path stops being only a line. It can become an orbit. And an orbit is an accusation. Something is pulling. Imagine a small light crossing a dark room. If it moved in a straight line, the story would be simple. But it does not. It curves slightly. It pauses in a rhythm too regular to be accident. It leans around a point where no lamp is visible. The room remains dark. The unseen object gives no face, no surface, no flash of arrival. Yet the light has betrayed it. That is the map made of wobbles. The visible star becomes the instrument. Its motion is the needle. The hidden companion is not discovered because it shines, but because the star cannot move as if it were alone. Gravity writes a signature into the sky, and Gaia reads that signature with repeated attention. This is where black holes begin to separate from ordinary darkness. A dark object is not automatically a black hole. The universe is full of things that fail to shine brightly. Faint stars, white dwarfs, neutron stars, planets, brown dwarfs, dust, cold debris. To call something a black hole, astronomers need more than absence. They need mass. They need orbit. They need limits on how much light the object emits. They need to ask whether any ordinary object could explain the same pull. That caution is not weakness. It is the only reason the claim has weight. If a visible star orbits an unseen companion, the orbit can reveal the companion's mass. The period, shape, and size of the orbit matter. So does the distance to the system. Gaia's parallax helps anchor that distance. Spectroscopy from other telescopes can add radial motion, showing how the star moves toward and away from us. Piece by piece, the three-dimensional behavior becomes harder to dismiss. The star becomes a witness, but not a perfect one. Its testimony must be checked. A black hole candidate is strongest when the unseen companion is too massive to be a white dwarf, too dark to be a normal star, and too compact in implication to be something familiar. The conclusion is not, we saw the black hole. The conclusion is, the visible star behaves as if it is orbiting a massive dark object, and the best explanation is a black hole. That sentence is less sensational. It is also more powerful, because it shows how the invisible becomes real inside science, not by imagination, not by fear, not by giving darkness a mythic role, by forcing all easier explanations to fail. Voyager cannot do this from its lonely path. It can measure what touches it, but it cannot watch 1 billion stars breathe across years. It cannot build a galactic census from tiny positional shifts. Distance did not give Voyager this authority. Precision gave it to Gaia. That reversal is the wound in the old adventure story. The far traveler is not the one making the black hole map. The mapper is closer to home, moving in a carefully chosen orbit, looking again and again at points of light so distant that they appear almost fixed to the naked eye. Gaia does not need to go to the black hole. It lets time expose the companion. There is something almost humiliating in that method. A black hole, one of the most extreme objects allowed by known physics, can be approached through the slight hesitation of an ordinary star, not through thunder, not through a visible abyss, through bookkeeping so exact that gravity has nowhere to hide. The sky, seen by eye, appears calm. Stars are pinned like cold sparks. A telescope gathers them. A detector records them. Years pass. The calm becomes false. Tiny motions accumulate. A point that looked solitary reveals a partner. A missing mass begins to take position, not as a picture, but as a demand made by the data. The map is not drawn with ink. It is drawn with residuals. A residual is what remains after the expected motion has been subtracted. It is the leftover disagreement between a simple model and a measured reality. Most leftovers are not revelations. Some are instrument error. Some are messy astrophysics. Some are caused by ordinary binary stars. But occasionally, after correction, checking, and follow-up, the leftover begins to point toward a hidden mass. This is why the phrase, "not where it should be," has to be handled with care. A star not where a simple model predicted it would be does not automatically mean a black hole has broken the map. It means the model was incomplete. Something else had to be added. Sometimes that something is mundane. Sometimes it is extraordinary. The extraordinary has to earn its place. Gaia's black hole discoveries are not frightening because they are nearby in any human sense. They are frightening because they prove how much can exist in the familiar sky without showing itself. A star can be catalogued, named, measured, and still carry a hidden partner whose presence is visible only through deviation. This changes what a map is. A map is not only where bright things are, it is where force has left a pattern. It is where motion refuses to remain simple. It is where the visible world bends around an absence and makes that absence measurable. In that sense, Gaia does map black holes. But it does not map them like cities. It maps them like debts. Every orbit is a ledger, and gravity is the balance that cannot be erased. The unseen object is not allowed to be mysterious for free. That is the discipline behind a black hole candidate. Darkness alone proves almost nothing. A gap in a picture can be dust. A missing star can be distance. A faint companion can be too dim for the telescope used to search for it. The universe contains many ways to hide without collapsing into an event horizon. So the first task is not to make the hidden object dramatic. The first task is to make every ordinary explanation suffer. A visible star moves. Its orbit says there is another mass in the system. That mass is not guessed from mood. It is extracted from motion. The star accelerates, slows, curbs, and returns. Its path carries a rhythm, and rhythm in a gravitational system is not decorative. It is measurement. The period of the orbit, the size of the motion, the distance to the system, and the mass of the visible star all begin to narrow the invisible companion. Somewhere in that narrowing, absence becomes uncomfortable. If the companion were a normal star, it should contribute light. Not always much, but something. If it were a pair of ordinary stars, the combined light and mass would have to fit the data. If it were a white dwarf, its mass would usually fall into a familiar range. If it were a neutron star, the mass and history would need to make sense. Each possibility is placed against the orbit like a key against a lock. Most keys fail quietly. A black hole remains when the hidden mass is too heavy, too dark, and too compact for the easier answers. That does not mean certainty becomes absolute. Astronomy rarely gives that kind of luxury. It means the claim has survived the pressure that should have broken it. The black hole is not accepted because it is exciting. It is accepted because the visible star has left too much debt for ordinary matter to pay. Listen to how strange that is. The evidence is not the black hole shining. It is the companion star refusing to move alone. It is light behaving as if darkness has weight. It is a curve in the sky that cannot be flattened without lying about gravity. This is why Gaia's work is so different from the old adventure the title wants to tell. Voyager enters a place and lets the place touch its instruments. Gaia watches from a distance and lets time turn motion into confession. One is contact, the other is accounting. And black holes often belong to accounting. A dormant black hole can be almost offensively quiet. If it is not feeding on gas, if no bright accretion disk surrounds it, if no violent jet points across space, it may offer no theatrical clue. It does not glow as a warning. It does not carve a visible hole in the star field. It can sit inside a binary system, while the visible star carries the whole burden of announcement. The sky keeps its calm face. Underneath, gravity is doing paperwork. A star swings around a common center of mass. That center may sit in empty-looking space. The star is not orbiting the black hole alone, in the simple picture taught by diagrams. Both objects orbit their shared center, but if one object is dark and massive, the visible star becomes the moving handle of an invisible machine. The black hole's presence is read through the handle. This is a hard kind of seeing. It asks us to trust relationship over appearance. It asks us to believe that an object can be placed on a map because another object has made room for it in its motion. It asks us to stop treating light as the only form of testimony. Light is only one witness. Gravity is another. The debt becomes clearer when distance is known. A star that appears to wobble slightly nearby may be moving through a small physical orbit. The same angular wobble farther away may imply a much larger path. Without distance, the orbit can lie by scale. Gaia's parallax helps fix that scale by measuring the tiny apparent shift caused by Earth's changing viewpoint around the Sun. Once the distance is better known, the star's motion can be translated from angle into physical size. The map gains depth. Spectroscopy can add another piece. A spectrum is not just color spread into a band. It can reveal motion along our line of sight through Doppler shifts, showing whether the star is moving toward or away from us at different times. The sky plane motion and the line of sight motion together make the orbit less flat, less ambiguous, more three-dimensional. A soft line in a spectrum shifts. A hidden mass tightens its outline. Still, caution remains. A wrong stellar mass can infect the companion estimate. An unseen luminous companion may be missed if observations are incomplete. A blended source can confuse the measurement. Binary and triple systems can mimic simpler stories. The data have to be cleaned, cross-checked, and resisted. The desired answer is not allowed to arrive early. This restraint is where the drama actually lives. Not in a forbidden object suddenly appearing where it should not be. In the long refusal to call absence a black hole, until absence has behaved with enough mass to deserve the name. Every careful limit removes one hiding place. Every follow-up observation asks the system to repeat its confession. Every failed ordinary explanation makes the dark companion less like a gap and more like a physical demand. The title wants a map. Gaia gives something more severe, a liability record written by stars. The visible star owes its motion to something. That debt must be paid by mass. If no light appears where enough mass should be, the universe has not become magical. It has become stricter. The missing light is not proof by itself. The orbit is not proof by itself. The mass estimate is not proof by itself. The strength comes from their convergence. Mass without light. Motion without a visible partner. A gravitational explanation that survives the attempt to replace it. That is how an invisible object takes up space in knowledge. It does not become less real because we cannot photograph it. In some ways, the opposite is true. A photograph can deceive with surface. An orbit must obey. The star cannot fake gravity over years simply because the human eye wants a picture. This is the invisible object leaving a visible debt. And the debt changes the meaning of the map. The map is no longer a catalog of bright points. It becomes a record of obligations, where stars must answer to unseen companions, where motion has been bent, where empty-looking regions contain enough mass to command light from a distance. Voyager's path is one line through the outskirts of the Sun. Gaia's sky is a ledger of countless lines, each one asking whether the star is alone. Most are. Some are not. And in those few refusals, the galaxy begins to show the shape of what it keeps dark. A shadow is not a photograph of a surface. That is where the Event Horizon Telescope has to enter carefully. The famous black hole images did something almost impossible, but they did not turn a black hole into a planet. They did not show a hard edge, a skin, a wall, or a glowing object sitting in space. They showed radio emission from hot material near a region where gravity bends light so violently that a dark center appears. The word image is true. The easy meaning of image is dangerous. For most of human history, seeing meant trust. A thing appeared because light left it, entered the eye, and formed a picture. A mountain could be distant, but its outline still belonged to rock. A moon could be cold, but its face still reflected sunlight. Even a star, reduced to a point, announced itself by shining. A black hole refuses that contract. Nothing inside the event horizon sends light back to us. The center is not dark because it is painted black. It is dark because paths that might have carried light outward are no longer paths to the outside universe. The absence is physical. It is made of geometry, not shade. But the region around a black hole can blaze. Gas spirals inward, magnetic fields twist, plasma heats to extremes, particles accelerate. Radio waves leave the chaos before crossing the point of no return. That outgoing radiation can reach telescopes, and if the resolution is sharp enough, the surrounding emission can reveal a dark depression where light has been captured or redirected. This is what the Event Horizon Telescope used. Not one telescope. A planet-sized instrument made by linking radio observatories across Earth. The method is called Very Long Baseline Interferometry, but the name is less important than the trick. Telescopes separated by continents observe the same source at the same time. Each site records the signal with extraordinary timing. Later, those recordings are combined, and the distances between telescopes act like pieces of a virtual dish as large as Earth itself. The Earth turns. The baselines change. A broken circle of measurements slowly fills part of an invisible aperture. There is a quiet mechanical beauty in that. Antennas in deserts, on mountains, on high dry plateaus, all listening to millimeter radio waves from gas near a black hole tens of thousands or millions of light years away. Atomic clocks keep time. Weather matters. Water vapor matters. A thin breath of atmosphere can blur a measurement from the edge of gravity. This is not a snapshot in the familiar sense. It is a reconstruction under constraint. The first image of M87 star, released in 2019, showed a bright asymmetric ring around a dark central region. The ring was not a solid object. It was emission from plasma shaped by gravity, motion, and relativistic effects. The darkness was not empty background. It was the black hole's shadow, a region where light paths near the event horizon are removed from the image or bent away from us. The result looked simple because the final picture was simple. The work underneath was not. To make that image, scientists had to turn incomplete radio measurements into a visual reconstruction without inventing what the data did not support. Several independent teams used different algorithms. They compared results. They tested whether the ring survived changes in method. They asked whether the structure was real or a consequence of human choices in processing. The ring remained. That survival mattered. A dramatic picture without discipline would have been worse than no picture. It would have given the public a symbol and stolen the uncertainty that made the symbol honest. The strength of the image came from restraint. Show what the measurements can bear. Test the reconstruction. Do not pretend the black hole has posed for a camera. Then, Sagittarius A star came later, closer and more difficult in a different way. The black hole at the center of the Milky Way is much nearer than M87 star, but its material changes more quickly as we observe it. Smaller mass means shorter timescales near the horizon. The source flickers, shifts, and evolves, while Earth-sized observations are being made. It is like trying to make a long exposure portrait of smoke around a drain, while the smoke refuses to hold still. The familiar sky hides that violence. In visible light, the galactic center is buried behind dust. In radio, with the right technique, the center becomes measurable, not as a monster with a face, not as a hole drawn in a starry cloth, as a compact gravitational object surrounded by turbulent emission, whose structure, after enormous correction, matches the expectations for a black hole. Again, the map is consequence. The Event Horizon Telescope does not show the event horizon as a surface, because the event horizon is not a surface in the ordinary material sense. It is a boundary in spacetime, a place after which outward return is no longer part of the future. Nothing has to be painted there. No wall has to stand there. The boundary is made by what paths can still lead outward. That is harder to imagine than a dark sphere. So the mind simplifies. It sees the ring and says, "There is the black hole." But the more accurate sentence is stranger. There is light from extremely hot material near a black hole, shaped by gravity into a structure that reveals the black hole's shadow. Less clean. More true. This distinction matters because images are powerful enough to become myths. Once a black hole has a picture, people can forget how much inference still lives inside the picture. They can forget the telescope network, the timing, the atmosphere, the algorithms, the model tests, the missing data, the disciplined doubt. They can treat the image as if a spacecraft flew close, opened a camera shutter, and returned a postcard from the abyss. That did not happen. No one went there. Earth listened to radio waves. This is why Voyager belongs in the contrast, even while it has nothing to do with the image. Voyager is a physical emissary. It crossed a boundary and measured the place around itself. The Event Horizon Telescope stayed home, or almost home, and turned Earth into an eye large enough to resolve the consequence of gravity at impossible distance. One instrument travels. The other enlarges the planet. Both reveal the failure of ordinary seeing. Voyager shows that going far does not automatically grant a wide view. The Event Horizon Telescope shows that staying near does not mean remaining blind. A map can be made by motion through a place, but it can also be made by synchronizing clocks, comparing waves, and extracting structure from interference. The black hole image is therefore not a violation of distance. It is a negotiation with distance. It accepts that the object cannot be approached, that the dark center cannot emit, that the data will be incomplete, that the atmosphere will interfere, that plasma will complicate interpretation. Then it asks, what can still be known? The answer is, not everything. But it is enough to make darkness take shape. A ring appears, bright on one side, uneven, almost fragile. The human eye wants to turn it into a cosmic wound, a burning mouth, a final proof of nightmare. The better response is quieter. The ring is not there to frighten us. It is there because matter near a black hole is hot, fast, magnetized, and forced to move through curved spacetime. The beauty is not separate from the mechanism. The beauty is the mechanism becoming visible. The shadow is real, but it is not a surface. It is a refusal in the path of light. A black hole can be mapped by the way space trembles after it is gone. That sentence sounds wrong until the instrument changes. Gaia watches stars. The Event Horizon Telescope listens to radio light. Voyager lets particles strike its aging sensors. Gravitational-wave astronomy uses something stranger. It turns distance itself into the detector. On Earth, long tunnels hold beams of laser light. Mirrors hang with extreme isolation. The beams split, travel down perpendicular arms, bounce back, and recombine. If the lengths of the arms remain unchanged, the returning light carries one pattern. If a gravitational wave passes through, space is stretched and squeezed by an amount almost too small for language. One arm becomes minutely longer, while the other becomes minutely shorter. Then the effect reverses. The machine does not hear a sound. It measures a change in length. But when the signal is translated into human perception, it can be heard as a chirp, a rising sweep, brief and clean, like a hidden animal crossing the edge of hearing. That chirp can be the last fraction of a second before two black holes become one. Nothing in that event is gentle. Two compact objects, each holding several or many solar masses, spiral around each other at enormous speed. As they orbit, they lose energy through gravitational waves. The orbit shrinks, the frequency rises. The final motion becomes faster than the mind can follow. Then the horizons merge, the distorted remnant rings down, and the new black hole settles into a quieter shape. By the time the wave reaches Earth, the violence has become almost nothing. A detector waits in Louisiana, Washington, Italy, Japan, or another linked site. A truck passing nearby matters. A tremor in the ground matters. Thermal noise matters. Quantum noise matters. The world is full of things louder than space-time. The instrument must reject nearly everything the planet does in order to notice what the universe has done. There is a strange intimacy in that. A collision that may have happened hundreds of millions or billions of years ago crosses Earth as a deformation smaller than an atomic nucleus across kilometers of instrument. The event is ancient before the detector feels it. The black holes may no longer exist as two objects. Their final dance is over. Yet the record arrives late, carrying mass, spin, distance, and a rough position on the sky. This is not a map like a photograph. It is a map made from ringing. When a gravitational wave passes through multiple detectors, the arrival times differ slightly. One site feels the wave before another. The shape and strength of the signal vary. From those differences, scientists estimate where on the sky the wave came from. The result is often not a precise dot. It may be a broad region, sometimes large enough to contain many galaxies, but it is still location. It is still a way of placing an invisible event in the universe. The black holes themselves do not need to shine. They do not need gas. They do not need a visible companion. They only need to move violently enough for spacetime to carry the news. This changes the meaning of darkness again. A dormant black hole in a quiet binary may hide from telescopes. A supermassive black hole may reveal itself through radio emission near its horizon. But two black holes merging can announce themselves without light at all. Their evidence is not electromagnetic, it is geometric. They disturb the metric of spacetime, and that disturbance travels outward at light speed. A thin wind moves over the detector buildings. Inside, the lasers remain locked. Computers compare templates against noise. The candidate signal rises, sweeps, and disappears. It does not look like an image of a hole. It looks like a curve whose shape has been predicted by general relativity and sharpened by decades of numerical modeling. The curve is the witness. From it, scientists infer the masses of the black holes before the merger, the mass of the final black hole, the energy carried away by waves, and sometimes information about spin. These are not read off like labels on a map. They are reconstructed by matching the observed waveform to models of compact objects spiraling together. The better the match, the stronger the inference. There is uncertainty here too. Noise can mimic pieces of a signal. Parameters can be correlated. Sky localization may be broad. Spins can be hard to measure cleanly. Distance estimates are not the same as tape measurements stretched across space. The event becomes known through probability, model comparison, detector calibration, and repeated checks. The confidence is real, but it is not the same as holding the object in view. That restraint matters because gravitational waves invite myth. The phrase sounds like a cosmic alarm bell. It is tempting to imagine Earth shaking under the impact of dead stars. But the planet does not shudder in any ordinary human sense. No glass moves, no water ripples, no sleeper turns over because two black holes merged far away. The wave passes through bodies, oceans, mountains, and cities almost without consequence. Only the instrument is delicate enough to be bothered. That is the body-scale translation that makes the discovery more severe, not less. A catastrophe larger than human violence crossed your bones and left no sensation. It needed kilometers of laser-stabilized patience to become noticeable. The universe is not quiet because nothing is happening. It is quiet because our bodies are crude instruments. Voyager, floating beyond the sun's wind, cannot feel this kind of map. A gravitational wave passes through it as easily as through Earth. The spacecraft is a point, not a kilometer-scale interferometer. Its loneliness gives it no advantage here. Again, the old grammar fails. The traveler does not become the witness. The witness is the system built to notice one very specific kind of distortion. Yet gravitational wave astronomy also gives Voyager's story a darker companion. Voyager measures the local medium after decades of travel. LIGO and its partners measure events no spacecraft could reach, from signals that have already crossed the universe without needing a carrier. One message comes from a machine we sent. The other comes from space-time itself. Both arrive weak. Both require trust in instruments. Both remind us that knowledge is often a rescue operation performed at the edge of noise. The black hole map grows through these rescues. Gaia adds dark companions by stellar motion. The Event Horizon Telescope adds shadow structures through radio interference. Gravitational wave detectors add mergers through strain. None gives the whole galaxy. None eliminates uncertainty. But each method opens a different door into the invisible, and the doors do not belong to travel alone. This is why the false headline keeps changing shape. At first, it sounded like Voyager had found a misplaced object. Then it became clear that Voyager's real achievement was boundary, not black hole. Gaia turned mapping into stellar debt. The Event Horizon Telescope turned shadow into constrained image. Now gravitational waves turn disappearance into soundless evidence. A black hole merger may leave no light. It may leave no wreckage visible to ordinary telescopes. But space remembers the violence long enough to carry it. And if the instrument is quiet enough, Earth can hear the memory pass. The midpoint error is not that we believed Voyager could reach too far. The error is that we believed reaching was the deepest form of knowing. That belief is older than spacecraft. It belongs to feet, ships, roads, caravans, probes, and flags. A human being learns the world by approaching it. The distant thing becomes real when the body arrives. The mountain is not only a shape on the horizon, it becomes rock under the hand. The ruin is not only a photograph, it becomes dust on the shoe. The ocean is not only blue on a map, it becomes salt, motion, sickness, weather, and the long creak of timber under strain. For most of history, this grammar made sense. Go there. See it. Return with proof. Voyager feels like the highest expression of that grammar. A machine leaves Earth, crosses planetary distance, survives the cold, and keeps speaking after the sun's wind loses command. It seems to carry our ancient method into the modern universe. Send a body outward, let it arrive, let arrival become truth. But black holes do not reward that method. Neither does most of the cosmos. This is the reversal the title accidentally opens. The universe did not become knowable because we reached it. It became knowable because we learned how to measure consequences. We learned how to let invisible things betray themselves through visible damage, visible motion, visible heat, visible timing, or invisible strain made measurable by machines. That is a different kind of courage. Less heroic to imagine, perhaps. Less clean than a probe entering darkness, but more powerful because it accepts the scale honestly. It does not pretend that every mystery can be crossed by metal. It does not shrink the Milky Way until a spacecraft can scout it like a coastline. It starts with the harder admission. Most of what matters will never be touched by anything we build. So the method changes. A star moves wrong, and Gaia waits long enough to prove the wrongness is not noise. A ring of radio emission forms around darkness, and the Event Horizon Telescope uses Earth itself as a broken lens. Two black holes merge, and gravitational wave detectors notice space-time stretch by an amount the body could never feel. None of these acts is a rival. Each is a form of listening. The map becomes an aftermath. Not where objects politely show themselves, but where consequences remain. This is why the word mapped has to be rescued from the false headline. A map does not have to begin with sight. In modern astronomy, a map may be a catalog of motions, a field of probabilities, a reconstructed image, a waveform archive, a mass distribution, a sky region, a set of residuals that refuse to vanish. It may say, here is where something unseen must be, because everything around it has paid the cost of its presence. The black hole itself does not step forward. The universe around it changes shape. That is enough. And yet, enough does not mean simple. Consequence can mislead. A wobble can come from more than one kind of companion. A ring can depend on plasma physics as well as gravity. A gravitational wave signal can carry parameter uncertainties. A dark object may be easier to name than to prove. The map grows only because each method disciplines the others. No single instrument becomes mythology. The evidence has to survive being doubted from several directions. This is where Voyager's limits become useful again. Voyager is not humiliated by these instruments. It clarifies them. It shows what direct contact can do and what it cannot do. Direct contact can tell us about the local plasma around one path. It can measure cosmic rays where the sun's shielding weakens. It can feel the boundary between solar wind and interstellar medium in the austere language of particles and fields. But direct contact cannot turn one path into the galaxy. A needle cannot describe the whole cloth by passing through one thread. The older adventure story wants the farthest machine to become the central witness. The deeper scientific story distributes witness across systems. One instrument travels. One measures stellar positions. One combines radio observatories across Earth. One suspends mirrors and watches laser light for impossible changes. Knowledge is no longer carried by one heroic body, returning from the edge. It is assembled from many partial senses, each blind in one way and precise in another. That may feel less romantic. It is not. There is a different romance in a civilization admitting that its body is too small, and then building senses larger than the body. A radio array stretches across continents because no single eye is enough. An astrometric spacecraft measures star positions because no human lifetime of looking upward can detect the needed precision. Interferometers wait in long corridors because no nerve can feel space-time pass. The universe is not being conquered. It is being negotiated with. A soft beep arrives from Voyager. A star's position shifts by a nearly imperceptible amount. A radio wave reaches a mountain observatory after crossing dust and magnetic fields and the warped neighborhood of a horizon. A laser pattern changes inside a detector on Earth. Each signal is fragile. Each could be noise if handled carelessly. Each becomes knowledge only after restraint. This is the midpoint because the story stops being about a mistaken object and becomes about a mistaken model of discovery. At the beginning, the question sounded almost geographical. Did Voyager find black holes where they should not be? Did a probe at the edge of interstellar space draw a map that broke expectation? That question has now collapsed, not because it was too dramatic, but because it was too small. The real question is harsher. How does a creature that learns by touching understand a universe it cannot touch? How does a civilization born under one star map objects thousands, millions, or billions of light years away? How does absence become evidence without becoming fantasy? The answer is not one instrument. It is not one mission. It is not one image released to the public with a bright ring and a dark center. The answer is method. Repeated measurement, model testing, cross-checking, uncertainty, correction, and the willingness to let the universe remain partly hidden even after a discovery. That last part matters most. A false headline hates uncertainty. It wants the old machine to find the forbidden thing. It wants placement, shock, revelation, a clean violation of expectation. Real astronomy is more patient and more severe. It says the black hole is not where a photograph places it. It is where mass, light, motion, and space-time together make every easier explanation fail. Voyager keeps moving through one local darkness. Meanwhile, nearer instruments map distant darkness by watching what it changes. The reversal is complete, but it is not comforting. If reaching is not the highest form of knowing, then humanity's greatest journeys are not enough by themselves. Our deepest knowledge may come from things we never visit, events already finished, objects that do not shine, boundaries that are not visible, and signals so weak they almost disappear before becoming meaning. The universe did not open because we arrived. It opened because we learned to read pressure, delay, absence, curvature, and tremor. It opened because we stopped asking darkness to show its face, and started asking what darkness had moved. The wrong place was not in the sky. That is the sentence the title has been trying to become. At first, it seemed to point outward, towards some black hole misplaced on a galactic map, some impossible object sitting where theory forbade it. That is the shape a headline wants, a cosmic address error, a discovery so clean it can be understood before breakfast. But the displacement was never that simple. The thing out of place was our expectation. We expected the farthest machine to have the deepest authority, because that is how human scale teaches us to think. A person who has gone to the frontier seems to know more than a person who stayed behind. A sailor who has crossed the ocean outranks the mapmaker at the desk. We trust the traveler because the traveler paid with distance. Voyager paid with distance. It paid with decades. It paid with silence between commands. It paid with power slowly fading inside radioisotope generators. It paid with instruments turned off, one by one, not because the questions ended, but because survival became a matter of choosing which senses the old machine could keep. If any artifact deserved the romance of final witness, it was this one. And yet that romance fails here. A low signal crosses the dark, caught by antennas that have to listen with ceremonial patience. The message is real. The journey is real. But none of that places a black hole onto a map. None of it turns the spacecraft into a galactic surveyor. None of it makes distance behave like wisdom. This is the harder correction. Distance can increase loneliness without increasing perspective. A probe can move farther from Earth while remaining trapped inside one thin line of experience. Voyager knows what touches it. That knowledge is precious because the place is unreachable to us, but it is also narrow. The spacecraft cannot widen itself into an observatory. It cannot become a billion-star census. It cannot stretch into an Earth-sized radio instrument. It cannot become kilometers of laser arms, waiting for spacetime to change length. It is a traveler, not an entire civilization of instruments. The mind resists that distinction because travelers are easier to love. They have narrative gravity. They leave. They endure. They become old in the dark. Instruments that stay nearer home feel less dramatic, even when their precision exceeds anything travel could give. A spacecraft moving outward feels like a story. A catalog of stellar motions feels like a database. But the database may know where the black hole is. This is not a failure of wonder. It is a correction of wonder. The romance belongs not only to motion, but to measurement. There is grandeur in a billion stars recorded until one reveals a hidden companion. There is grandeur in radio dishes separated by continents behaving like pieces of a single planetary eye. There is grandeur in lasers held so steady that a passing gravitational wave can be distinguished from Earth's noise. These are not lesser adventures. They are adventures without footsteps. A dark object does not care what story we prefer. It does not become more discoverable because a machine is far away. It becomes discoverable when some measurable consequence escapes it. A companion star bends, gas heats, light forms a ring around a shadow. Spacetime carries a chirp from a merger that ended before its signal reached us. The universe gives evidence in the form allowed by physics. That is why the phrase, "where it should be," is so treacherous. Where should a black hole be? In a neat diagram? At the center of a galaxy? In a violent X-ray binary? At the end of a massive star's life, safely far from ordinary stars? In public imagination, black holes belong to dramatic locations. Centers, catastrophes, visible danger. But many do not. Some may sit quietly in binary systems, known only because another star's path has become slightly wrong. Some may drift without feeding, invisible unless chance or motion exposes them. The wrongness is not that a black hole appears in some forbidden place. The wrongness is that we expected the galaxy to arrange its darkness according to our narrative instincts. A starfield looks innocent because our eyes are poor historians. They see points. They do not see long-term acceleration, hidden mass, orbital debt, gravitational memory, or the selection effect that decides which dark objects become visible to science. The naked sky is not simple, it is undermeasured. Calm is not evidence of emptiness. Stillness is often only motion too slow, too distant, or too subtle for the body to catch. That is the scale wound again. The body is built for nearby causes. A branch cracks, and we turn. A flame gives heat, and we pull back. A face changes, and we read danger or welcome. Our nervous system is a local instrument, sharpened by survival at meters and seconds. It is not built for light years, parallax, orbital periods, waveform templates, or signals delayed across interstellar distance. So we translate the cosmos into older stories. Traveler finds thing. Farther means closer to truth. Darkness means danger. Picture means proof. Nearby means reachable. Each translation helps the mind enter the subject. Each can betray the subject if left uncorrected. The black hole was not where the title said, because the title had placed knowledge in the wrong instrument. It had put the map inside Voyager, as if going outward must eventually make the invisible appear. But black holes are found where evidence permits them to be found. And evidence may come from a star's patient wobble, rather than from the bravest machine ever sent away from home. There's a quiet cruelty in that. Voyager can be heroic and irrelevant to the black hole map. Both things can be true. The spacecraft keeps moving. Its signal continues to thin. The sun behind it becomes less dominant in its measurements, but not absent from its story. It carries human intention into a region no human body can enter. It has changed the way we understand the heliosphere and the conditions beyond the planetary neighborhood. It has done exactly the kind of work only contact can do. But black hole mapping belongs mostly to consequence. And consequence does not respect our preferred symbols. The wrong place, then, is not a coordinate error. We place the crown on the traveler because we confuse distance with sight. We imagine the old probe lifting a lantern at the edge of the sun's weather and seeing the hidden architecture of the galaxy. The real lanterns are stranger, a star not quite where it should be, a radio fringe recorded at two telescopes separated by an ocean, a laser pattern shifting inside a sealed corridor, a faint hiss in one instrument, a soft beep in another, a curve in data that refuses to flatten. That is where the map begins. Not at the edge of adventure, but at the edge of error. At the point where the expected motion fails, where the model cannot explain the residue, where the image remains dark in a way ordinary darkness cannot account for. Discovery begins when the universe refuses to match the simpler story. Voyager taught us one refusal. It showed that the solar system is not merely a list of planets, but a bubble of solar influence with a boundary that can be crossed and measured. Black hole astronomy teaches another. It shows that the universe is not merely a collection of luminous objects, but a structure of forces, absences, and consequences, many of which become real to us only when something else is disturbed. The title still has a pulse because wrongness remains. Something was not where it should be. Not the black hole. The human mind. The unfinished census begins with a simple problem. Most black holes do not owe us an announcement. They can exist without feeding. They can drift without a glowing disk. They can sit in binary systems where the companion star is still too faint, too distant, or too poorly measured for the hidden mass to be recognized. They can move through the galaxy without bending any light strongly enough for us to notice. They can be real and remain absent from every catalog, because nothing nearby has been forced to betray them. This is not a gap in drama. It is a gap in selection. Astronomy often discovers what the universe has made detectable, not what the universe contains in full. A bright object enters the record easily. A violent event enters the record if its signal reaches the right instrument at the right time. A quiet object may sit inside the same galaxy, obeying the same laws, carrying the same mass, and still leave no practical trace for us to separate from the background. The map is therefore not the territory. It is the territory filtered by visibility, timing, geometry, sensitivity, and luck. A black hole feeding on gas can become almost theatrical. Matter spirals inward, heats and radiates before the horizon. X-rays may flare, jets may form. The surrounding region can become bright enough to reveal the hidden mass by the violence of what falls toward it. That kind of black hole enters human knowledge with force. It disturbs its surroundings loudly enough to become a target. But many black holes may not be feeding at all. A dormant black hole is a different problem. Without nearby gas, without an unfortunate companion losing material, without a merger, without a star whose orbit we can measure cleanly, it may be almost silent. Its gravity remains, its event horizon remains, its mass remains. But knowledge does not follow existence automatically. Something has to carry information from the object to us. If nothing carries it, the black hole is not disproven. It is uncounted. That word matters more than it seems. Uncounted is not imaginary. Uncounted is not rare. Uncounted is the natural state of much of the universe before instruments become sensitive enough, surveys long enough, and methods clever enough to find what was previously hidden in absence. A city at night can be mapped by its lights, but that map fails the closed rooms, sleeping bodies, cellars, buried pipes, locked archives, and pressure in the water mains. Light gives one truth and hides another. The galaxy is worse. It contains bright stars that dominate the eye, while quieter masses shape motion from underneath. The black hole census is built through biases. X-ray surveys find systems that are active in X-rays. Radio observations find sources that produce radio emission. Astrometric missions find companions whose visible stars move enough, for long enough, in a way the instrument can resolve. Gravitational wave detectors find mergers whose waves pass through Earth while the detectors are operating and sensitive. Microlensing can reveal compact objects when their gravity briefly magnifies a background star, but only if alignment, timing, and monitoring cooperate. Each method opens one door. Each door faces a different hallway. None opens the whole house. This is why any black hole map should feel provisional, not weak, provisional, strong inside its methods, incomplete outside them. Gaia can reveal certain dark companions and binaries, but it cannot reveal every isolated black hole drifting without a luminous partner. LIGO and its partners can reveal merging black holes, but not the population of quiet black holes that never merge during the age of observation. The Event Horizon Telescope can image horizon-scale structures around a few supermassive black holes, but not turn the Milky Way into a complete atlas of collapsed stars. The census is unfinished because the universe is not equally loud everywhere. Some black holes shout through accretion. Some whisper through stellar motion. Some ring once through spacetime and vanish as separate objects. Some may say almost nothing for billions of years. A faint crackle runs through the record, not because the galaxy is empty, but because our receiving systems are selective. We hear certain kinds of disturbance and mistake the audible fraction for the whole orchestra. The danger is not ignorance alone. The danger is confusing the catalog with reality. That mistake has happened before in astronomy. The known universe has often expanded when a new method began seeing what older methods missed. Radio astronomy revealed a sky different from the optical sky. Infrared light pierced dust that visible light could not cross. X-rays exposed violent, compact objects. Gravitational waves opened a channel where no light was required at all. Each new sense did not merely add objects. It changed what an object could mean. The same is true for black holes. A black hole found through X-rays feels like hunger. A black hole found through Gaia feels like debt. A black hole found through gravitational waves feels like a vanished collision. A black hole imaged by the Event Horizon Telescope feels like shadow made measurable by surrounding fire. These are not just poetic differences, they are detection differences. They decide which parts of the population become visible and which remain behind the method's blind side. So when a newly identified black hole seems surprising, the surprise may belong partly to nature and partly to the survey that finally noticed it. An object may look misplaced because the previous map was never complete. It may look unusually nearby because the nearer quiet population was harder to see. It may seem rare because we only knew the loud ones. The map improves, and the universe appears to move. But often, nothing moved. Only the instrument changed. This is the proper way to keep wonder without lying. We do not need to pretend that Voyager mapped a forbidden structure. We do not need to invent a black hole in the wrong place. The honest version is already severe. The galaxy contains an unknown number of collapsed objects, and our awareness of them depends on fragile pathways of evidence. Some are found because they consume, some because they pull, some because they collide. Some because they silhouette themselves against heated surroundings. And some remain outside the census. This unfinishedness should not feel like failure. It is the condition of a science that has not confused its instruments with the universe. A mature map admits its blank regions. It marks the difference between absence of evidence and evidence of absence. It knows that darkness can be empty or merely quiet, and that quietness has no duty to make itself convenient. Voyager's silence between signals helps return the scale to the body. An old machine speaks from one path beyond the sun's wind. Earth listens and learns one narrow truth. Around that same galaxy, black holes may exist along countless other paths that no machine crosses, no companion betrays, no gas illuminates, no merger announces during our watch. Their reality does not bend toward our schedule. The census waits on patience. Longer baselines, cleaner measurements, deeper surveys, more sensitive detectors, better models, new channels of evidence. The map will grow, but unevenly, shaped by what black holes do and by what our instruments can notice. That is the hidden humility inside every catalog. A catalog looks authoritative because it has names, coordinates, masses, uncertainties, and dates, But behind every listed object is a larger darkness of things not yet listed, not yet measured, not yet made to confess through motion or light or tremor. The galaxy's black hole map is not a finished portrait. It is a record of encounters between invisible mass and available evidence. The rest is still out there, not necessarily farther away, not necessarily stranger, not necessarily dangerous. Just uncounted. Near is one of astronomy's most misleading kindnesses. It sounds merciful. It sounds like a thing has been brought within reach, or at least within imagination. A nearby shop can be walked to. A nearby city can be reached before night. A nearby planet can become a mission, a launch window, an engineering problem surrounded by budgets, failures, and stubborn hope. A nearby black hole is not nearby in that sense. When astronomers describe one of the closer-known stellar black hole systems, the word is doing work inside a scale so large that ordinary language begins to crack. Gaia BH1, for example, is called nearby because it is close compared with most black hole systems we know. It is not close compared with Voyager. It is not close compared with any machine humanity can send. It is not close compared with grief, patience, generations, or the lifetime of a civilization trying to cross interstellar space by chemical or nuclear inheritance from the 20th century. It is nearby the way a mountain on the moon is nearby to another galaxy. The word survives. The body does not. A light year is already a discipline. It takes the fastest thing in the universe and gives it a year. Then it asks us to treat the result as a unit. Gaia's nearby black holes sit hundreds or thousands of those units away. Light itself needs centuries or millennia to make the crossing. The visible companion star we measure is not being seen as it is now, but as it was when the photons began their long passage toward our instruments. That delay is not decoration. It means every map of the distant universe is also an archive. When Gaia measures the wobble of a star bound to an unseen companion, it is not watching a live performance in the human sense. It is receiving old light with exquisite discipline. The star's motion has been translated across time, distance, detector, algorithm, and model. The black hole candidate enters the catalog not as a neighbor at the door, but as an event of evidence arriving late. The loneliness of Voyager makes this more physical. The spacecraft is far enough that commands take hours to arrive. Its signal returns after crossing a span that already defeats normal conversation. Engineers cannot touch it, repair it, or hurry it. The distance imposes a new rhythm on care itself. And yet this delay is almost intimate beside 1,000 light years. A command to Voyager is patience. A black hole at Gaia distances is history. That is the contradiction hidden inside nearness. The nearest known black holes are not future destinations. They are nearby entries in a map made by creatures who cannot go there. We can assign coordinates, we can estimate mass, we can infer an orbit, we can compare possible explanations and reject the weaker ones. But the object remains beyond practical approach by such an absurd margin that the word near becomes almost a confession of helplessness. It tells us the map is not made for feet. It is made for evidence. Imagine placing Voyager on a road, if such a road could exist, and pointing it toward one of these systems. The spacecraft would continue beyond the heliopause, beyond the fading influence of solar wind, beyond every object it was built to understand. Its transmitter would fail, its heat would vanish into the dark, its instruments would fall silent. It would become a cold artifact moving through interstellar space, still obeying inertia, still carrying the golden record, still shaped by human hands. The destination would not grow meaningfully closer. No engine burn would follow, no camera would wake, no final approach would begin. The spacecraft's entire active life would be a small mark near the starting line. Even after silence, even after Earth forgot the exact operational details, even after language changed around the memory of the mission, the black hole would remain a distance that light measures easily and matter does not. That is not a reason to despair. It is a reason to stop confusing reach with relevance. The object can be unreachable and still scientifically near. Its companion star can wobble in a way our instruments can measure. Its mass can enter a table. Its distance can be improved. Its system can teach us about stellar evolution, binary formation, supernova remnants, and the quiet population of collapsed stars that does not advertise itself through hunger. Unreachable does not mean unknowable. This is one of the most important corrections in the entire story. The human imagination often treats knowledge as a substitute for arrival. If we cannot go, perhaps we only have symbols. But astronomy is not merely symbolism at a distance. It is physical information arriving through light, motion, waves, particles, and fields. A star's spectrum is not a poem about chemistry. It is chemistry writing itself into light. An orbit is not a metaphor for mass. It is mass acting over time. A gravitational wave is not an analogy for violence. It is a change in spacetime crossing the detector. The problem is not unreality. The problem is access. Nearness in astronomy is therefore not a promise of visitation. It is a promise of better measurement. A closer system may give a larger parallax, a clearer motion, a stronger chance for follow-up, a better constraint on mass. It may allow astronomers to reduce uncertainty and test models more sharply. That is what near means inside the map. Not reachable. Less impossible to measure. There is a muted beauty in that severe definition. It removes the tourist instinct from the sky. It forces us to admire not the fantasy of arrival, but the exactness of relation. A black hole can be near enough for its companion star to become a witness, and still too far for any ship to matter. The star gives us the object's gravity long before engineering can offer us the object's neighborhood. The witness arrives first. The traveler may never arrive at all. Voyager makes that order unforgettable. It is moving through space in the old heroic way, and we love it for that. But Gaia's nearby black holes are known through a newer and colder kind of intimacy. We do not stand beside them. We watch what they make another body do. We do not cross the distance. We let distance carry evidence back, then spend years learning how not to misunderstand it. A soft paper rustle in an archive might be the better sound for this than a rocket. Not launch thunder, not engine fire. A record being opened, a table being corrected. A star's motion, once ordinary, becoming strange enough to preserve. The nearness that matters is not the nearness of travel. It is the nearness of constraint. When the orbit is measured well enough, when the visible star's light is understood well enough, when the hidden companion's mass becomes too heavy for ordinary explanations, the black hole moves closer in knowledge while remaining impossibly far in space. That is the paradox the title could never hold in its first form. The map improves without the body advancing. The object becomes clearer without becoming accessible. And somewhere beyond the sun's weather, Voyager continues along its single line, teaching the opposite lesson from the one the headline wanted. Even the farthest traveler can be irrelevant to a nearby black hole. Even an unreachable black hole can be present in the data. Nearness is not one thing. It is a hierarchy. Near to light, near to measurement, near to inference, near to imagination, near to touch. Only the last one belongs to us naturally. The others had to be invented. The instruments do not agree because they are identical. They agree because each is blind in a different way. That is the reason the black hole map becomes stronger as it becomes less like a single picture. A civilization that had only Voyager would know one thread of interstellar space. A civilization that had only Gaia would know motions on the sky with astonishing precision, but not the plasma around a horizon. A civilization that had only the Event Horizon telescope would see a few extreme shadows and remain ignorant of many quiet, dark companions. A civilization that had only gravitational-wave detectors would hear collisions, but not the silent population between them. None of these instruments is enough. Together, they begin to correct the shape of ignorance. Voyager is the sense of touch, not touch as skin understands it, but contact through exposure. Its instruments sit inside the medium they measure. Particles arrive, fields pass through, plasma waves leave signatures. The spacecraft cannot survey the galaxy, but it can tell us what one region beyond the sun's wind does to a machine actually there. That kind of knowledge has a narrow honesty. It does not pretend to see everything. It says, Here, along this path, at this time, the environment changed this way. A faint beep crosses the dark and becomes local truth. Gaia is not touch. Gaia is memory sharpened into geometry. It watches stars so carefully that stillness breaks open. A star that seemed alone reveals curvature. A point that looked pinned to the sky becomes a moving body with a hidden obligation. Gaia does not need the black hole to shine. It needs the companion star to fail at solitude. Its blindness is also its power. Gaia is not built to feel cosmic rays beyond the heliopause. It is not built to image the region near an event horizon. It is built to measure where stars are, how they move, and how those motions change when something unseen holds mass nearby. The galaxy becomes a ledger. The Event Horizon Telescope is a different organ again. It does not count every black hole. It cannot give us the quiet inventory. It turns Earth into an aperture and asks whether radio emission near a horizon-scale region can be reconstructed into structure. Its image is partial, model-tested, and constrained by incomplete measurements. It is not the black hole itself smiling for a camera, but it gives darkness an edge made by surrounding light. That edge matters, not because it explains every black hole, but because it shows that general relativity, plasma emission, and Earth-sized radio interferometry can meet at the boundary of what ordinary sight can never resolve. A mountain observatory listens, a desert dish records, a high plateau waits under thin air. Later, their separated signals become one damaged but disciplined eye. The shadow survives the reconstruction. That survival is a kind of testimony. Then, gravitational wave detectors add a sense no eye could imitate. They do not ask for light. They do not ask for a companion star. They wait for spacetime itself to carry the aftermath of compact objects spiraling together. The black holes may be invisible before the merger and invisible after it. Yet for a fraction of time, their motion becomes a wave that crosses the universe and changes the lengths of detector arms on Earth. A laser pattern shifts. The vanished pair enters the record. This is not the same map Gaia makes. It is not the same map EHT makes. It is not Voyager's map of local particle weather. It is a catalog of events, not just objects. It tells us that black holes do not merely sit in the galaxy like dark stones. They form, pair, orbit, merge, and leave behind heavier remnants. They have histories written in mass and spin, even when no light accompanies the violence. Each instrument therefore changes the question. Voyager asks, where does the sun's local influence give way? Gaia asks, where does visible motion require hidden mass? EHT asks, where can light near extreme gravity be reconstructed into a shadow? Gravitational wave detectors ask, where did spacetime ring because compact objects merged? These questions overlap, but they are not interchangeable. That is why one instrument cannot be crowned as the master witness. The universe is too large, too quiet, too indirect, too uneven in what it reveals. Knowledge has to become plural. It has to accept that one kind of evidence may be precise about location and weak about history, while another may be strong about mass and weak about sky position, while another may be local, direct, and cosmically narrow. A mature map carries these asymmetries. It does not hide them. There is a human lesson inside that, but it should not be made too sentimental. The lesson is not simply that many perspectives matter. The sharper truth is that reality exceeds any single sense. The body pretends the eye is sovereign, because vision has served us well near the ground. But black holes break the monarchy of sight. They demand witnesses that are not eyes. Clocks, lasers, spectra, stellar catalogs, radio phases, particle counters, magnetic field records, waveform templates. The universe is not one object viewed from one window. It is a set of pressures crossing different instruments. In that sense, Voyager is not excluded from the black hole story because it failed. It is excluded from black hole mapping because its sense is tuned to another truth. Its limitation makes the whole system clearer. You would not ask an ear to measure color. You would not ask a thermometer to draw a face. You would not ask a spacecraft on one interstellar path to inventory collapsed objects scattered across the Milky Way. The right instrument is not the most romantic one. It is the one whose blindness matches the question. That is why the correction to the title becomes more than a correction. It becomes an anatomy of knowing. The false headline gathered all authority into the old traveler. The real map distributes authority across a civilization's extended senses. Some are in deep space, some orbit near Earth, some stand on mountains, some lie in long corridors on the ground. Some exist as archives, algorithms, error bars, and repeated observations across years. The map is not one revelation. It is a negotiation among partial witnesses. A soft relay click from Voyager, a tiny displacement in a star catalog, a radio fringe recorded through atmosphere and weather, a brief gravitational chirp rising out of noise. None sounds complete alone. None deserves worship, but together they do something no human body can do. They let absence acquire coordinates, mass, history, and uncertainty. The uncertainty is not a stain on the map. It is part of the map's honesty. Every error bar marks the place where knowledge did not pretend to be larger than its evidence. Every broad sky localization admits that the signal was real, but the address remains loose. Every reconstructed image remembers the data gaps beneath it. Every astrometric orbit carries assumptions that must be tested. Every Voyager measurement is local enough to be precious and too local to become universal. This is how the invisible is handled without turning into myth. Not by forcing all instruments to tell the same story, by letting each correct the other's temptations. Sight wants a picture, motion demands mass, touch insists on local condition, strain records catastrophe without light. When these senses overlap, the dark object becomes harder to dismiss. When they disagree, the disagreement itself becomes information. The galaxy's black hole map is therefore not an atlas drawn from above. It is a listening practice spread across machines. And the more carefully those machines disagree, the more trustworthy the darkness becomes. The silence around the map is not empty. It is crowded with things that have failed to become evidence. That is the most difficult truth to hold after all the instruments have spoken. Gaia finds a wobble. The Event Horizon Telescope rebuilds a shadow from radio waves. Gravitational-wave detectors catch the last tremor of a merger. Voyager feels the local medium beyond the sun's wind. Each success feels like a door opening. Each success also reveals how many doors remain shut. A map of black holes is therefore surrounded by silence. Not poetic silence, not the decorative darkness of a dramatic sky, a technical silence, an observational silence, the kind that appears when a real object produces no signal strong enough, timely enough, clean enough, or distinct enough to enter the record. This silence has structure. Some of it comes from distance. Light weakens, detail shrinks, motion becomes slower across the sky. A companion star that might betray a black hole nearby becomes too faint or too crowded to read farther away. The wobble is still there in reality, but not in the measurement. The object has not vanished, only our access has failed. Some silence comes from timing. A merger can send gravitational waves across the universe, but if it happened before our detectors existed, the signal passed through an Earth that had no way to notice. A black hole can feed for a time, flare, quiet down, and leave behind no convenient announcement for the century in which we happen to be watching. The universe does not schedule its evidence around the age of our instruments. Some silence comes from geometry. A system may be turned the wrong way. A jet may point elsewhere. A companion orbit may hide part of its motion from us. A gravitational wave signal may arrive from a sky region that remains broad because of detector placement and sensitivity at the time. The fact exists, but the angle withholds it. That is why absence is never simple. A dark patch may mean nothing is there. It may mean something is there but quiet. It may mean something is there but poorly aligned. It may mean our model is incomplete, our instrument too crude, our survey too short, or our confidence too eager. The discipline of astronomy is learning not to confuse these silences. The body is bad at that. In ordinary life, silence becomes meaning quickly. A room goes quiet, and we feel a tension. A phone does not ring, and we invent a reason. A machine stops humming, and the absence becomes a warning. We evolved inside a world where missing sound could matter immediately. A snapped twig, a still forest, a breath held behind a wall. Silence felt like presence. The universe punishes that instinct too. Most cosmic silence is not aimed at us. It is not waiting. It is not hiding with intention. It is only the natural condition of objects whose information has not reached the right instrument. The silence around a black hole map is not secrecy. It is physics plus limitation. A dormant black hole does not need to announce its gravity and light. An isolated one may pass through the galaxy without a companion bright enough to betray it. It can hold several solar masses inside darkness, and still make no entry in any catalog. No gas falls, no star wobbles within our detection. No merger occurs during our watch. No lensing alignment happens at the right moment. Nothing speaks. The object remains. That should change how the map feels. A normal atlas reassures us by filling space with names. A black hole map should unsettle us by making every name feel like an exception. The listed objects are not simply the population. They are the population that intersected our methods. They are the visible tips of an invisible bookkeeping system, selected by motion, heat, collision, timing, and accident. A paper rustles in an observatory office. A table is updated. A new candidate is added with uncertainty beside it. The number grows. The blank space around it does not disappear. It becomes more articulate. That is the strange gift of a good map. It teaches the shape of what it cannot yet show. The better black hole astronomy becomes, the more carefully silence must be classified. Unknown is not the same as impossible. Unseen is not the same as absent. Unmeasured is not the same as unreal. But suspected is not the same as known. A mature science lives inside these separations. It refuses both panic and laziness. It does not fill every darkness with monsters. It also does not mistake the visible catalog for the full machinery of the galaxy. This is where the title's old drama looks childish. A fake version says, Voyager found the thing, and it was not where expected. The real version says, our expectations fail because most of the map is made from what can barely be detected, and the undetected part may be vast. Not one forbidden object, not one shocking coordinate, a whole galaxy filtered through the fragile conditions required for evidence. That is darker than the false version. And calmer. Because it does not need conspiracy, panic, or a miraculous probe. It only needs the truth that reality exceeds its record. The universe is not obligated to be observable in the forms we prefer. It can contain mass without light, violence without a visible flash, motion too slow for a short survey, signals too weak for current detectors, and distances that turn active systems into old news by the time their evidence arrives. The silence around the map also changes Voyager. The old spacecraft becomes not a revealer of everything, but a reminder of how narrow any signal is. Its own message arrives as a fragile survival, a low-power transmission crossing distance, carrying local measurements from one path. It is precious because so much else says nothing. It is precious because a signal is not the normal state of the cosmos. A signal is an accident of design, energy, geometry, and endurance. Black holes are not designed to speak to us. When they do speak, they speak indirectly, through a star's hesitation, through plasma forced into heat, through a ring rebuilt from radio waves, through spacetime stretched and released, through a background star briefly brightened by gravity, through the failure of simpler explanations. And when they do not speak, the silence is not a gap in the story. It is part of the story's mass. The last third begins here, because the question has become larger than black holes. It is about the arrogance of complete maps. It is about how easily knowledge turns into a finished-looking surface. A chart can look calm. A catalog can look final. A number can look like ownership. But every honest measurement carries a shadow of what it could not measure. The sky above Earth remains visually serene. Stars hold their cold positions. The Milky Way spreads like pale dust in dark places where human light has not erased it. Beneath that calm are motions, remnants, mergers, dead cores, failed signals, and hidden companions. Some have entered evidence, many have not. The silence is not a lack of structure. It is structure waiting for the right disturbance. The map grows when silence breaks in a measurable way. Until then, the darkness is not empty. It is undecided. The farthest machine and the nearest blindness are not opposites. They belong to the same wound. Voyager is far because matter had to travel there. Metal had to survive launch, radiation, cold, time, and the slow theft of power. Every kilometer was paid in physics. The spacecraft did not become distant by being imagined. It became distant by moving, by carrying its instruments outward through the planetary system and past the wind of the sun until Earth became less a place than a direction for its signal. That kind of distance has moral weight. It feels earned. A radio command leaves Earth and cannot be hurried. It crosses the dark at light speed, which sounds absolute, until the distance makes even light feel patient. The old machine receives the instruction much later, if it receives it at all. Then a reply begins the return. There is no conversation. There is only delayed care, a ritual of sending and waiting, while the spacecraft continues into a region no human hand can repair. A faint carrier tone arrives at Earth. Inside it, one path through space becomes measurable. That is Voyager's greatness. It teaches through exposure. It is not guessing the local interstellar medium from a safe distance. It is inside one small portion of it, letting particles and fields become data. Its knowledge is narrow, but it is direct. It is the difference between reading about rain and hearing rain strike metal above your head. But directness is not the same as completeness. This is the blindness nearest to us. The human mind wants to promote proximity into truth. If something is touched, it must be known. If something is reached, it must be understood. If an instrument is physically there, surely it outranks an inference made from here. The instinct feels solid because it works on Earth. A stone in the hand is less ambiguous than a rumor of a stone. A ruin underfoot is more persuasive than a drawing of ruins. Cosmic scale breaks that instinct without asking permission. Voyager touches one environment and cannot see the whole system that contains it. It can cross the heliopause and still know almost nothing about the black hole population of the Milky Way. It can become the farthest emissary of Earth and remain blind to the hidden masses that nearer instruments infer through stars, radio waves, and spacetime. The old machine is far. Its blindness is close to ours. We share it because our bodies were built for local truths. We trust what resists the hand. We trust what reflects light. We trust what makes sound, heat, pressure, smell, pain, or motion near us. We are animals of contact. Even our imagination of space keeps returning to contact. Landing, crossing, entering, seeing, bringing back proof. A black hole refuses almost all of that. It has no surface we can touch from the outside in any ordinary way. It may emit no light of its own. It may sit in a system where only another star's motion gives it away. Its strongest boundary is not a wall, but a division in possible futures. Beyond the event horizon, paths that lead outward no longer exist. That is not an image made for mammals. It is geometry with consequences. So we keep simplifying it. A hole, a monster, a mouth, a place. Those images are useful until they begin to lie. The more accurate black hole is not a place waiting for a spacecraft. It is a relation between mass, space-time, light, and motion. It becomes visible to knowledge when those relations disturb something that can carry information outward. A companion star, a heated disk, a radio wave, a gravitational waveform, a background star briefly magnified. The thing itself remains more severe than the image we use to approach it. Voyager's limit helps strip the image down. Picture the spacecraft now, not as a triumphant explorer discovering forbidden objects, but as a small surviving instrument beyond the sun's weather. It moves through cold, with no audience except mathematics and memory. The planets it visited are behind it. The cameras are silent. The golden record is mute unless someone finds it, and no one likely will. Its body is not dramatic in the dark. It is just there, continuing. A thin hiss of imagined static follows it. That image is powerful because it is honest. It does not pretend the spacecraft sees everything. It lets the loneliness remain local. It lets the achievement remain bounded. Voyager is not important because it became omniscient. It is important because it shows what one measured path can mean when every path beyond Earth is almost impossible. The same humility belongs to black hole maps. Gaia does not know every dark companion. The Event Horizon Telescope does not image every horizon. Gravitational-wave detectors do not hear every merger. Each instrument is a partial answer built against blindness. Each makes one kind of silence break. The mature wonder is not that we have overcome blindness. We have organized it. We have learned which blindness can be reduced by patience, which by baseline, which by timing, which by sensitivity, which by better models, and which must remain for now. The map is a treaty between evidence and ignorance. It shows what has been forced into measurement and leaves room for what has not. That is a harder beauty than the false headline offered. A false headline gives the old probe a revelation and asks us to feel awe. The real story gives us an aging spacecraft, a billion-star survey, a planet-sized radio array, laser interferometers, incomplete catalogs, uncertainty, and silence. It asks for a slower awe. It asks us to understand that the universe is not hiding because it enjoys secrecy. It is hiding because reality is not automatically information. Information needs a path. Voyager is one path. Starlight is another. Radio waves are another. Gravitational waves are another. A spectrum, an orbit, a parallax, a timing residual, a statistical confidence, an error bar, a signal rescued from noise. These are not cold replacements for wonder. They are the channels through which wonder survives contact with truth. The nearest blindness is the belief that truth should look like arrival. Voyager denies that gently. It arrived at a boundary and showed us the boundary was not everything. It crossed into interstellar space and revealed not the galaxy entire, but the next layer of local condition. Its greatness became more precise when the mythology was removed. Black holes do the same to sight. They remove the mythology that seeing is owning. They teach that a thing can be real because of what it prevents, what it bends, what it accelerates, what it hides, what it leaves ringing after collision. They make absence active. They force knowledge to become indirect without becoming imaginary. By now, the title has almost inverted itself. Voyager did not map black holes because it was not the instrument for that blindness. It mapped another blindness, the one surrounding our home star, the invisible shelter we lived inside without feeling its edge. Black hole astronomy maps a different blindness, the invisible masses we know through their effects. Both maps are incomplete. Both are true. Somewhere beyond the sun's wind, Voyager continues moving through one measurable darkness. Somewhere in the same galaxy, black holes continue shaping motions we have not yet measured, mergers we have not yet heard, shadows we have not yet resolved. Between them is not a failure of science, but the condition science was built for. A small signal, a vast silence, and the discipline to know the difference. The place things really are is rarely the place the first story puts them. At the beginning, the title seemed to send us outward with Voyager, beyond the sun's wind, towards some hidden black hole map supposedly drawn in the wrong part of space. That was the bright lure. An old spacecraft, a forbidden discovery, a cosmic object where it should not be. The shape was familiar enough to feel possible, and dramatic enough to feel urgent. But the truth has been quieter and more severe. Voyager did not map black holes. It mapped a boundary of home. Gaia did not visit black holes. It measured the motions of stars until hidden mass became difficult to deny. The Event Horizon Telescope did not photograph a surface. It reconstructed radio emission around darkness shaped by gravity. Gravitational-wave detectors did not see two black holes collide. They measured spacetime after the collision had already become a signal. Every part of the story removed a simpler picture and replaced it with a harder one. That is what the universe keeps doing to us. It accepts our first images only long enough to break them. The solar system is not merely planets around a star. It is also a bubble of wind and magnetic influence pushing into the interstellar medium. A nearby black hole is not nearby enough for travel. It is nearby enough for measurement. A photograph of a black hole is not a portrait of a thing with a surface. It is a constrained image of light that survived the neighborhood of no return. A map is not always a drawing of visible places.
Sometimes it is a ledger of consequences.
The title said something was not where it should be. Now the sentence has changed. The black hole was not misplaced. The certainty was. We had placed knowledge inside the traveler. We imagined that the machine farthest from Earth must have earned the deepest vision. That instinct belongs to bodies that learn by walking, touching, entering, and returning. It belongs to explorers on oceans, surveyors in mountains, archaeologists in ruins, witnesses standing close enough to say, "I was there." But the cosmos is not arranged around that kind of witness. Most of it will not be reached. Many of its most important objects will never be touched. Some will not shine. Some will speak only through motion. Some will announce themselves once, as a wave, and then become a remnant. Some will remain uncounted because no companion, no gas, no alignment, no detector, and no century of observation gave them away into evidence. The universe is not withholding a secret. It is larger than our natural ways of knowing. A faint signal comes in from Voyager. It has traveled across the region where the sun's weather gives way to something colder and older. The signal is weak, delayed, almost absurdly small against the dark. Yet it matters because it carries contact. One machine is still being touched by a place we cannot enter. Somewhere else in the same galaxy, a star makes a slight curve around an invisible companion. Somewhere near a supermassive black hole, plasma heats, brightens, and releases radio waves before light paths become hopeless. Somewhere far beyond any mission plan, two black holes have already merged, and the old violence is still traveling outward as a ripple. None of these signals is the whole truth. Each is a narrow mercy. That is what a scientific map becomes at this scale. Not possession, not conquest, not a final picture, but a disciplined arrangement of narrow mercies. Enough light survived, enough motion accumulated, enough timing held, enough noise was rejected, enough doubt was allowed to remain. From that, a coordinate appears, a mass estimate appears, a shadow appears, a waveform appears, a boundary appears. And around each appearance, the darkness remains larger. This should not make the map feel weaker. It should make it feel honest. A map that admits its edges is more trustworthy than a map that pretends to be the world. The blankness around black hole catalogs is not failure. It is the pressure that keeps the known objects from becoming mythology. It reminds us that every discovery is also a statement about what conditions allowed discovery to happen. Voyager's final role in this story is not to become a black hole instrument. It is to remain itself. An aging spacecraft moving through one line of interstellar space, carrying the memory of giant planets, silent cameras, fading heat, a record no one may ever hear, and a signal Earth still chooses to catch. It is not less beautiful because it did not find the forbidden thing. It is more beautiful because its real work is smaller, stricter, and true. It tells us where one kind of shelter ends. That shelter was invisible to almost everyone who ever lived inside it. No ancient city saw the heliosphere. No sailor felt the heliopause in the wind. No child looking at the night sky could sense the solar bubble enclosing the planets. The boundary was real before it was known. It shaped the conditions of home before home had instruments delicate enough to notice. Black holes teach the same lesson in reverse. Their reality does not depend on our seeing them. Their gravity acted before our catalogs. Their mergers rang before our detectors. Their companion stars moved before Gaia named the dead. Their shadows existed before radio telescopes were synchronized across Earth. Knowledge arrived late, not because the universe began late, but because our methods did. This is the final mirror. We live inside systems we do not feel, under protections we did not build, among forces we notice only when something disturbs the visible world. The ordinary sky is not ordinary. The quiet map is not complete. The farthest spacecraft is not far in the way the galaxy uses distance. The nearest black hole is not near in the way the hand understands nearness. We are always translating from a human body into a universe that never promised to fit inside one. Still, the translation works sometimes. That is the astonishing part. A machine built in the 1970s can still tell us about the edge of the sun's influence. A star's wobble can reveal a collapsed companion. A ring of radio brightness can expose the shape of darkness. A laser beam on Earth can register the last moment of objects that swallowed their own light. These are not substitutes for truth. They are how truth reaches creatures like us. So the title survives only after being emptied of its false miracle. Voyager just mapped black holes. Number. Voyager mapped the limits of travel. Black hole astronomy mapped the power of consequence. And together they mapped something more intimate, the place where human intuition fails and measurement begins. The old spacecraft continues outward. It is not heading toward the answer. It is carrying one answer away from us, slowly, faithfully, until silence takes the transmitter and the signal becomes memory. The black holes remain where gravity, history, and evidence place them. Some named, some inferred, some still uncounted, none arranged for our comfort. Nothing was where the first story said it should be. Not Voyager. Not the black holes. Not us. The real map was never only of space. It was of the distance between wanting to see and learning how to know.